Look up at the night sky on a clear evening, and you might see a beautiful tapestry of stars scattered across the darkness, a serene and peaceful vision of the cosmos. But that tranquil view is an illusion, a comforting lie we tell ourselves from the safety of our tiny world. The universe is not a gentle, silent expanse waiting to be explored. It is ancient, vast, and filled with terrors beyond our comprehension. Out there, in the crushing emptiness between galaxies, forces are at work that defy imagination, phenomena so strange and violent they could unravel reality itself. Have you ever wondered what truly hides within that infinite blackness, just beyond the edge of human vision? What nightmares might be waiting where light itself seems to fade into nothing? Today, we're setting aside the comforting stories of constellations and cosmic wonder to venture into the dark heart of the universe. We're going to explore 25 of the most horrifying, mind-bending phenomena ever discovered, phenomena that challenge everything we think we know about space, time, and our place in the cosmos. This isn't just a list of scary facts. It's a journey into the unknown, a descent into the abyss where the laws of physics twist into impossible shapes and where the very fabric of existence seems to fray at the edges. From black holes that trap light and time to phantom galaxies made of dark matter, from rogue planets drifting through eternal night to the chilling possibility that we might not be alone in the silence, each revelation will pull you deeper into a world of thrilling cosmic dread. So prepare yourself. What you're about to witness will shift your perspective forever, replacing that peaceful starry sky with something far more real, far more awe-inspiring, and infinitely more terrifying. This is the universe's dark side, and once you see it, you'll never look up at the night the same way again. Our journey into the cosmos's darkest corners begins not with a distant star, but with an absence, a perfect, silent nothingness moving through the void. Imagine an object with the mass of a star compressed into a point so dense that not even light can escape its gravitational pull. Now, imagine that object is not anchored at the center of a galaxy, but is instead untethered, drifting through the interstellar darkness like a phantom shark in an endless ocean. This is the reality of a rogue black hole, and it is one of the most unsettling concepts in modern astronomy. These cosmic predators are born from chaos. When massive stars, many times larger than our Sun, reach the end of their lives and explode in supernova, their cores can collapse into black holes. Usually, the immense force of such an explosion is symmetrical, kicking the newborn black hole away from its birthplace with unimaginable velocity. Some theories suggest these wanderers could also be the ancient remnants of the early universe, cast out during violent galactic collisions billions of years ago. Whatever their origin story, they are set adrift, traveling at incredible speeds on trajectories we cannot predict. The true horror of a rogue black hole lies in its perfect camouflage. A typical black hole is often surrounded by an accretion disk, a whirling vortex of superheated gas and dust that glows with intense radiation, betraying its location. A rogue black hole traveling through the near-perfect vacuum of interstellar space has no such dinner plate. It is alone, utterly dark, and virtually undetectable by any telescope we possess today. We would not see it coming. The first sign of its approach might be a subtle, inexplicable gravitational wobble in the outer planets of our solar system, a slight perturbation in the orbits of comets in the distant Oort cloud. By the time its influence began to visibly distort the paths of Neptune or Uranus, it would already be far too late. The devastation would be absolute yet silent. There would be no dramatic impact, no colossal collision. The black hole's gravity would simply begin to shred our solar system apart. Planets would be pulled from their orbits and stretched into streams of incandescent gas in a process called spaghettification. The Sun itself would be consumed, its light extinguished as it is torn into a swirling ribbon of plasma and drawn across the event horizon into oblivion. The entire intricate structure of our solar system, every planet, every moon, every asteroid, would be erased without a trace, leaving behind only an imperceptibly more massive black hole continuing on its silent, random path through the galaxy. The chilling possibility is that this isn't just science fiction. Astronomers estimate there could be millions of these nomads lurking in the Milky Way alone, their paths hidden in the overwhelming dark. But if the silent, unseen threat of a rogue black hole represents a hidden danger, the next horror is a cataclysm of unimaginable scale that is not only visible but utterly inevitable. We now turn from a lone predator in the dark to a violent, cosmic feast billions of years in the making, a process astronomers call galactic cannibalism. Our own galaxy, the Milky Way, is not a serene island universe. It is a product of this violent history, a cosmic predator that has consumed smaller galaxies in the past, and it is now on a direct collision course with another giant. The Milky Way and the Andromeda galaxy, our nearest major galactic neighbor, are locked in a gravitational embrace, hurtling towards one another at a speed of about 250,000 miles per hour. In approximately 4.5 billion years they will meet. The term collision is a bit misleading, evoking images of a cosmic car crash. The reality is both more chaotic and strangely beautiful, a slow-motion gravitational dance that will utterly reshape our corner of the universe. Because galaxies are mostly empty space, the stars within them are unlikely to physically smash into one another. Instead, the real horror and the incredible violence comes from the invisible force of gravity itself. As the galaxies first begin to intertwine, their immense gravitational fields will act like tidal forces on an oceanic scale, warping the delicate structures of both spirals. Stars will be plucked from their ancient orbits and flung into entirely new trajectories, some catapulted out into the intergalactic void never to return, others sent careening on wild new paths through the merging chaos. The serene orbital clockwork of our solar system will be completely disrupted. From Earth, the night sky would transform into a terrifyingly beautiful spectacle. The familiar band of the Milky Way would warp and distort as Andromeda grows from a smudge of light to dominate the entire heavens, its dusty lanes and brilliant clusters filling the night. The sky would no longer be dark, it would be ablaze with the light of billions of new stars, a constant, shimmering reminder of the impending chaos. This gravitational turmoil will last for billions of years, a drawn-out process of interaction and merger until the two galaxies eventually form a new, larger elliptical galaxy, often nicknamed Milkomeda. The peaceful spiral structures of both our galaxies will be erased forever, replaced by a more amorphous, egg-shaped collection of stars. Our solar system will likely be flung much farther from the new galactic core, into a lonelier and darker outer region, or perhaps even ejected entirely, becoming a true orphan of the cosmos. This isn't a distant theoretical concept. The Hubble Space Telescope has already confirmed this fate. Galactic cannibalism is not the exception in our universe, it is the rule. We live in a cosmos where the large consistently consume the small, a never-ending cycle of creation through destruction that operates on a scale so vast it defies human comprehension. Our galaxy has a violent past and an even more violent future, and we are along for the ride. Yet for all the immense, galaxy-shattering power of a collision like the one awaiting the Milky Way, the event would still unfold within the familiar confines of our universe's laws of physics. But what if the very framework of reality itself, the constants and laws that make atoms bond and light travel, is not as stable as we believe? This brings us to a theoretical horror so profound it dwarfs all celestial cataclysms, a concept known as vacuum decay. To understand this, we must think of the universe not as empty space, but as a field of energy. Modern physics suggests that what we perceive as a vacuum is not truly empty. It's filled with a fundamental field called the Higgs field. This field is responsible for giving particles their mass, and it's the reason our universe looks and behaves the way it does. Crucially, this field exists in a particular energy state, often called a false vacuum. Think of it like a ball resting in a small dip on the side of a very steep hill. It seems stable, but it's not in the absolutely lowest possible energy state, the true vacuum at the very bottom of the hill. It's perched, and a sufficiently powerful nudge could send it rolling all the way down. The terrifying implication is that our entire universe and everything in it is built upon this precarious perch. At any moment, in any place, a random quantum fluctuation could provide that nudge, causing a tiny bubble of true vacuum to spontaneously form. The laws of physics inside this bubble would be completely different. The fundamental constants we rely on, the strength of gravity, the speed of light, the forces that hold atomic nuclei together, would be rewritten into a new, alien set of rules. In this new state, the very building blocks of matter as we know it could become impossible. Atoms might not be able to form, chemistry and therefore life would cease to exist. This bubble would then expand in all directions at the speed of light. There would be no warning, no way to see it coming. Any signal that could alert us would travel at the same speed as the bubble itself. 1 nanosecond, our universe would exist. The next, it would be gone, replaced by a new reality with a different fundamental nature. From our perspective, the end would be instantaneous and total. Every star, every planet, every living thing in the entire cosmos would simply stop existing, not in a blast of fire and energy, but in a silent, perfect erasure of the physical laws that allow existence itself. This isn't an explosion in the universe, it is the universe itself and everything in it being permanently and irrevocably rewritten. The most chilling aspect of vacuum decay is its sheer inevitability if the theory is correct. It could have already happened in a distant galaxy, and the wave of obliteration could be on its way to us right now, traveling at light speed, or it could happen a billion years from now. Or it could happen before this sentence ends. It is the ultimate cosmic gamble, a game of quantum Russian roulette on a universal scale where the trigger could be pulled at any random moment, ending everything forever without a sound. While the silent erasure of vacuum decay represents a fundamental unraveling of reality itself, the cosmos also possesses more direct and violently explosive ways to sterilize entire worlds. If a gamma-ray burst were to occur anywhere near our solar system, it would unleash a cataclysm of pure energy, a flash of radiation so intense it would make the fury of a supernova seem like a gentle candle by comparison. These events are not merely powerful, they are the single most explosive phenomena known to exist in the universe since the Big Bang itself, and they serve as a stark reminder that space is filled with unimaginable random violence. A gamma-ray burst is the universe's ultimate death ray, a tightly focused beam of extreme energy that can leap across billions of light years. They are thought to be born from the deaths of the most massive stars or from the mergers of incredibly dense objects like neutron stars. In the final moments of such an event, the dying star doesn't just explode outward in all directions. It channels its entire apocalyptic energy into two narrow jets erupting from its poles, shooting out into the cosmos like a lighthouse beam of pure annihilation. For a brief moment, often lasting only from a few milliseconds to a few minutes, a single gamma-ray burst can outshine every single star in its entire host galaxy combined, releasing more energy than our Sun will emit over its entire 10 billion-year lifespan. The true horror of a gamma-ray burst lies in its focused lethality. If one of these jets were pointed directly at Earth from even a moderately nearby distance, say, within a few thousand light years, the consequences would be instantaneous and irreversible. The first sign would be a flash of light so brilliant it would be visible even in the middle of the day, a silent, blinding blaze in the sky. But this light is not the harmless visible light we see from the sun. It is an onslaught of high-energy gamma radiation, the same type of radiation released by nuclear explosions, only billions of times more powerful and concentrated. This initial wave of radiation would strike our atmosphere like a cosmic tsunami. It would violently rip apart the molecules in our upper air, initiating a chain reaction of chemical transformations. The most catastrophic effect would be the complete and rapid destruction of the ozone layer, our planet's essential shield against the sun's own harmful ultraviolet rays. In a matter of seconds, this protective blanket that took eons to form would be utterly obliterated. The burst would then be followed by a prolonged afterglow of lower energy radiation, bathing the planet's surface in a deadly shower for days or even weeks, effectively cooking any life exposed to the sky. The aftermath is where the true extinction-level event would unfold. With the ozone layer gone, the sun's unfiltered ultraviolet radiation would pour down onto the planet, causing severe radiation burns in animals and humans and devastating the base of the food chain. Phytoplankton in the oceans, which produce a significant portion of Earth's oxygen, would be killed off en masse. The radiation would also trigger chemical reactions in the atmosphere, creating a thick, brown smog of nitrogen dioxide that would blot out the sun, plunging the planet into a prolonged artificial winter that would halt photosynthesis and collapse ecosystems globally. The combination of instant radiation damage, acid rain, sudden climate change, and mass starvation would likely lead to one of the worst extinction events in our planet's history, potentially ending complex life entirely. What makes this scenario so profoundly unsettling is the element of random chance and the complete lack of any possible defense. A gamma-ray burst could be happening right now in a distant galaxy, and its lethal jet could already be on its way to us, traveling at the speed of light. We would have no warning whatsoever until the radiation itself began striking our atmosphere. The first signal of our doom would be the doom itself. Astronomers have found evidence suggesting a gamma-ray burst might have been responsible for the Ordovician extinction event 450 million years ago, which wiped out an estimated 85% of marine species. Our galaxy is not densely populated with the kind of hypergiant stars that produce these bursts, but the possibility, however small, is a chilling reminder that we exist in a cosmic shooting gallery where the bullets are beams of pure energy fired at random from the depths of time and space. Yet for all the terrifying power of a gamma-ray burst, its destruction is at least a known quantity, a colossal release of energy within the rules of our universe. But what if the cosmos itself is being pulled against its will towards something we cannot see and do not understand? This brings us to a mystery that has puzzled astronomers for decades, a gravitational paradox known as the Great Attractor, a cosmic tractor beam of unimaginable power dragging our entire galactic neighborhood toward an unseen fate. For years, scientists mapping the large-scale motion of galaxies noticed something deeply strange. Our entire local group of galaxies, including the Milky Way and Andromeda, is not moving randomly. Instead, we are all hurtling through the void at an astonishing 14 million miles per hour toward a specific point in the sky, located in the general direction of the constellation Centaurus. This motion is in addition to the overall expansion of the universe. It's a peculiar velocity, a deviation that suggests something with immense gravitational influence is pulling us. That something was dubbed the Great Attractor. The plot thickens, however, because when astronomers tried to look directly at this point in space to see what was pulling us, they found nothing. Or at least nothing they could easily see. The location of the Great Attractor lies directly behind the plane of our own Milky Way galaxy, in a region astronomers call the Zone of Avoidance. This is not some mystical forbidden area, but a practical observation problem. The disk of our galaxy is thick with cosmic gas, dust, and countless stars. This creates a visual wall that blocks our view of the universe beyond, much like trying to see a distant mountain range through a dense, blinding fog. For decades, the heart of this mystery remained hidden behind this interstellar veil, leading to rampant speculation. Was it a massive, unseen structure, a colossal black hole of impossible size, or something even stranger? The mystery began to unravel with more advanced technology, particularly telescopes that can see in wavelengths of light other than visible light, such as infrared and radio waves. These instruments can peer through the galactic dust. What they revealed was not a single, impossible object, but something almost as staggering, an enormous concentration of mass known as the Laniakea supercluster. Our Milky Way, it turns out, is merely a suburb on the outskirts of this vast cosmic metropolis, which contains over 100,000 galaxies. The Great Attractor appears to be the gravitational center of this supercluster, a central hub of immense density known as the Norma cluster, which acts as the core gravitational anchor pulling everything in our local universe toward it. So the mystery is solved, right? Not quite. While we've identified the general source of the pull, the true nature of the Great Attractor's immense gravity remains a topic of intense study. The visible mass of the Norma cluster and the surrounding galaxies, while huge, doesn't seem to fully account for the strength of the pull we experience. This suggests that a significant portion of the attraction is likely caused by something we still cannot see directly, an enormous amount of dark matter, the mysterious invisible substance that makes up most of the universe's mass coalesced in that region. The Great Attractor, therefore, is likely the brightest visible tip of a much larger, much darker iceberg. This realization transforms the horror of the Great Attractor from a fear of a single monstrous entity to a more profound unease about the fundamental nature of our universe. We are not just being pulled toward a point in space, we are being drawn toward the hidden skeleton of the cosmos itself, toward a concentration of dark matter so vast it can dictate the motion of countless galaxies. It is a humbling reminder that the visible universe, the stars and galaxies we see, is just a tiny fraction of what's actually out there. The true architects of cosmic structure are invisible, their presence only betrayed by their gravitational influence on the things we can see. Our entire galaxy and everything we know is caught in the current of a dark river, flowing toward an unseen destination we are only just beginning to map. But the universe has a way of defying even our most fundamental assumptions about life and death, creating horrors that resurrect from their own ashes. We call these cosmic phantoms zombie stars, and they represent one of the most violent and bizarre second acts in all of astronomy. These are stellar corpses that refuse to stay dead, clawing their way back into a semblance of life by feeding on the very stars that once called them companions, only to ultimately destroy everything around them in a cataclysmic rebirth. The most common type of stellar zombie is the white dwarf. When a star like our Sun dies, it doesn't explode. It gently puffs off its outer layers, leaving behind an incredibly dense, Earth-sized core of ultra-compressed carbon and oxygen. This is a white dwarf, a hot, dead cinder that will slowly cool over trillions of years into a cold, black lump of cosmic coal. But this peaceful end is only guaranteed if the white dwarf is alone. If it has a binary companion, a living star orbiting close enough, the corpse can awaken with a monstrous hunger. The white dwarf's immense gravity begins to strip material, primarily hydrogen, from its living neighbor. This stolen gas doesn't just fall onto the dead star's surface. It accumulates in a dense, swirling atmosphere, piling on layer after layer. With each passing moment, the pressure and temperature at the base of this stolen shroud build to insane levels. For a time, this process creates a beautiful but violent phenomenon known as a nova, where the accumulated hydrogen ignites in a runaway thermonuclear explosion on the surface, blasting the material into space in a brilliant flash that can make a dead star visible from Earth for weeks. But a nova is just a firecracker compared to the true resurrection. If the white dwarf continues to feed, stealing mass at just the right rate, its entire existence hangs in a terrifyingly precise balance. There is a critical threshold, a limit known as the Chandrasekhar limit, which is about 1.4 times the mass of our Sun. If the accumulating mass pushes the white dwarf over this limit, the outcome is not a surface explosion but a complete and utter detonation of the entire star. The incredible pressure reignites fusion in its core, not in a stable way, but in a runaway chain reaction that rips the white dwarf apart from the inside out in a titanic Type 1a supernova. This explosion is so perfectly uniform and unimaginably bright that it can briefly outshine an entire galaxy. In a single, violent instant, the zombie star is completely annihilated, leaving behind nothing but an expanding cloud of glowing debris and the traumatized remains of its companion star. This is the ultimate cosmic betrayal, a dead star using its partner as a fuel source to achieve a final, glorious, and mutually destructive apocalypse. Yet, if the thought of a resurrected dead star consuming its neighbor is unsettling, the universe has crafted an even more precise and relentless engine of destruction from another type of stellar corpse. When a star much more massive than our Sun dies, it doesn't leave behind a white dwarf. It collapses in a supernova so violent that it crushes the core into a ball of neutrons so dense that a single sugar cube-sized piece of it would weigh as much as a mountain. This is a neutron star, and some of them evolve into the most accurate timekeepers in the universe and the most deadly. These are the pulsars, the universe's ultimate lighthouses, but they don't guide ships to safety. They mark reefs of certain annihilation. A pulsar is a neutron star that spins, and it spins fast. As the original star collapsed, its rotation sped up dramatically, the same way an ice skater spins faster by pulling their arms in. A newborn pulsar can rotate hundreds of times per second. Coupled with an immense magnetic field trillions of times stronger than Earth's, this creates a phenomenal effect. The magnetic field accelerates particles to near light speed, forcing them to stream out from the magnetic poles in two powerful, focused beams of radiation. Because the magnetic axis is often tilted away from the rotation axis, these beams sweep through space like the beams of a frantic cosmic lighthouse. From our perspective, we detect a pulse of radiation every time a beam sweeps across the Earth. A blink of radio waves, X-rays, or gamma rays with a metronomic regularity that rivals atomic clocks. The horror of a pulsar is not in its appetite but in its unforgiving environment. Any planet that somehow managed to form around a pulsar or wander too close would be subjected to a constant, hellish barrage. The surface of a neutron star is a nightmare landscape where gravity is so strong it would spaghettify a human in a microsecond, and magnetic fields are so powerful they could tear apart atoms from thousands of miles away. But the true danger is the radiation. Those lighthouse beams contain enough concentrated energy to sterilize a planet instantly, scorching its surface with X-rays and gamma rays and blasting away any atmosphere in a relentless periodic onslaught. A world orbiting a pulsar would be baked and flash-fried with clockwork precision, its surface pulsing between unimaginable heat and the bitter cold of space in a deadly rhythm dictated by the spin of a dead star's heart. It is a tombstone that spins, a monument to a star's death that actively prevents life from ever taking root in its vicinity again, marking its territory with twin sides of pure radiation that sweep through the galaxy forever. But if the Great Attractor represents a hidden center of gravity within our observable universe, an even more profound and unsettling mystery lurks at the very edge of everything we can possibly see. Astronomers have detected a phenomenon that suggests our entire cosmos on the largest scales is not just expanding but is being pulled, as if by some unseen hand from a place beyond existence itself. This enigma is known as dark flow. The story begins with the aftermath of the Big Bang. The universe is expanding, with galaxies all rushing away from each other, a concept we've understood for nearly a century. But in the early 2000s, a team of scientists led by astronomer Alexander Kashlinsky were studying the cosmic microwave background radiation, the faint, leftover heat from the Big Bang that permeates all of space. This radiation is incredibly uniform, but it contains tiny fluctuations, a blueprint of the infant universe. As they studied the motion of enormous clusters of galaxies, they noticed something that should be impossible. These colossal structures, each containing thousands of galaxies, were all moving in the same direction at phenomenal speeds of over 2 million miles per hour. This motion was in addition to the overall expansion of the universe. It was a coordinated, coherent flow, a current in the cosmic ocean, and it was pointing toward a specific patch of sky between the constellations of Centaurus and Vela. This wasn't a pull from something inside our universe like the Great Attractor. The scale was all wrong. The Great Attractor's influence is local on our supercluster. Dark flow, however, was detected in galaxy clusters billions of light-years apart, and they were all moving in the same direction. The gravitational source for such a coordinated motion would have to be so immense, so distant, that it lies far beyond the observable horizon of our universe. According to our standard models of cosmology, nothing that exists outside our observable universe should be able to affect anything inside it. The space between us and whatever is out there is expanding faster than the speed of light, making any kind of influence, especially gravitational, seemingly impossible. And yet, the evidence suggests it is happening. This leads to a terrifying and mind-bending conclusion. The only conceivable explanation is that something of unimaginable mass, existing in a realm completely separate from our own, is exerting a gravitational pull on our entire cosmos. One of the most compelling theories is that dark flow is evidence of other universes. In the multiverse theory, our universe might be just one bubble in a vast cosmic foam of innumerable other universes, each with its own physical laws and properties. If a neighboring universe happened to be extremely close to ours in the multiverse landscape during the initial moments of the Big Bang, its gravitational influence could have become imprinted on the fabric of our own cosmos, setting entire clusters of galaxies on this mysterious coordinated drift. We are, in a very real sense, feeling the gravitational tide from another reality. Another, even more exotic possibility is that the structure of spacetime itself is fundamentally different on the largest scales than we currently understand. Perhaps gravity can leak through the boundaries between universes, or maybe our understanding of how gravity operates over these incredible distances is profoundly incomplete. The phenomenon of dark flow challenges the very definition of our reality. It implies that our universe is not a self-contained, isolated system. We may be part of a much larger, multidimensional structure, and the forces at play in that grander arena are capable of reaching in and steering the course of our entire existence. We are like sailors on a ship, feeling the pull of a current whose source lies beyond the horizon, in an ocean we cannot see and can scarcely imagine. While the concept of dark flow pulls our imagination toward the very boundaries of reality and other universes, there is a different kind of emptiness within our own observable cosmos that is equally unnerving. It is not a pull toward something, but a staggering, overwhelming absence of everything. If you were to point a telescope toward the constellation of Boötes, the herdsman, you would be aiming at one of the most profoundly lonely places in the entire universe, a region of space so empty it has been called the Great Nothing, the Supervoid, or more formally, the Boötes Void. Discovered in the 1980s by astronomers Robert Kirshner and his colleagues, the void is not just a small, dark patch between stars. Its scale is almost impossible to comprehend. It spans a diameter of approximately 330 million light-years. To put that in perspective, our entire Milky Way galaxy is a mere 100,000 light-years across. You could fit tens of thousands of galaxies like our own within this volume of space, and yet you would find almost nothing, where a region of this size should contain at least 10,000 galaxies. Based on the average density of the observable universe, surveys have only found a paltry 60. That means over 99.9% of the space within the void is just nothing. It is a cosmic desert of unprecedented scale, a spherical pocket of near-total emptiness that seems to defy the fundamental principle that matter is distributed somewhat evenly throughout the cosmos. The existence of such a void immediately sparks a terrifying question. What could have possibly cleared out a volume of space that large? The leading scientific theory points to a phenomenon known as hierarchical structure formation. In the early universe, small density fluctuations began to gravitationally attract matter, eventually growing into the vast cosmic web of filaments and clusters we see today. The flip side of this process is that the areas between these structures were left behind, becoming immense voids. The Boötes void could simply be the largest of these empty bubbles, a natural, if extreme, result of the universe's evolution. Perhaps several smaller voids merged over billions of years, creating one colossal empty region. It's a statistical possibility, albeit a very rare one. But its sheer scale has led to more speculative and far more chilling possibilities. Could the void be the result of some kind of catastrophic ancient event? One hypothesis suggests that an advanced Type 3 civilization on the Kardashev scale, a civilization capable of harnessing the energy of an entire galaxy, might eventually learn to construct hypothetical megastructures called Dyson spheres, enveloping stars to capture their entire energy output. Now imagine a civilization so vastly ancient and powerful that it didn't stop at one star. It began systematically harvesting the energy of every single star in its galactic neighborhood, eventually expanding its sphere of influence to encompass not just a galaxy, but an entire supercluster of galaxies. Over millions of years, it could theoretically enshroud every star in a region of space hundreds of millions of light-years wide. From our distant vantage point, that entire region of space would appear dark, silent, and utterly empty. The light of its stars would be gone, converted into energy for a purpose we cannot fathom. The Boötes void in this terrifying scenario would not be a natural desert. It would be a harvested field, a monument to the ultimate power of a civilization so advanced it appears godlike to us, and a stark warning that the silence we hear from the cosmos might not mean we are alone, but that everyone else has already been consumed. Yet, even this startling idea pales before another, more natural cosmic horror. The void's emptiness might be evidence of a past collision with something from outside our universe. Some theoretical physicists have proposed the existence of defects in the very fabric of space-time, relics from the universe's super-hot early moments. One such defect is a cosmic texture, a kind of knot in the primordial fields that formed during the Big Bang. If such a texture moved through the region we now call the Boötes void, its immense gravitational energy could have violently repelled all matter, literally pushing galaxies away and clearing out a perfect sphere of nothingness. It would be like a razor dragged through the foam of the cosmic web, leaving a smooth, empty scar in its wake. This texture would have continued moving at the speed of light, disappearing into the unknowable distance billions of years ago, leaving behind only this perfect, spherical clue to its unimaginable passage. The true terror of the Boötes void is not in what it contains, but in the questions its emptiness forces us to ask. Is it a simple, if colossal, accident of nature? Is it the ultimate trophy of a hyper-advanced civilization that mastered the stars eons ago? Or is it the scar of a primordial monster, a knot in space-time that tore through our universe and erased everything in its path? We may never know for sure. It serves as a humbling reminder that our maps of the cosmos are still incomplete, and that the darkest patches on those maps might hide the most profound secrets or the most unimaginable horrors. But within this grand dance of galaxies and the silent drift of dark flow, there exists a more personal, more direct form of cosmic violence. Imagine a star not drifting lazily through its galactic neighborhood, but hurled out into the intergalactic void like a stone from a sling, moving so fast it defies the very gravitational pull of its home galaxy. These are hypervelocity stars, and they are some of the most terrifying projectiles the universe has to offer, born from the most violent events imaginable. The primary engine for this stellar catapult is the supermassive black hole that lurks at the center of most galaxies, including our own Milky Way. This central monster is a gravitational titan, and it often exists as part of a binary system, not with another black hole, but with a companion star locked in a deadly orbital dance. If a third star happens to wander too close to this precarious pair, the black hole's immense gravity can capture it, violently disrupting the binary system. In a process known as the Hill's mechanism, one of the three stars is slingshotted away at an incomprehensible speed, while the other is captured into a tight orbit around the black hole, doomed to eventually be consumed. The ejected star doesn't just meander away, it is flung out on a hyperbolic trajectory, achieving escape velocity from the entire galaxy. We're talking about speeds that can exceed 2 million miles per hour, a velocity so great it could get you from Earth to the Moon in under 15 minutes. These stars become permanent exiles, cast out from the stellar cities of their birth to wander the immense, light-year-spanning deserts between galaxies. Their journey is one of profound loneliness, traveling through regions of space so empty that the light from their home galaxy would eventually fade to a faint, forgotten smudge. But the true horror of a hypervelocity star is not its solitude, it is its potential as an agent of pure, undirected destruction. Think of it as a cosmic bullet, and the universe is its shooting range. The danger lies in its passage through occupied territory through a galaxy like our own, or even worse, through a developed planetary system. If such a star were to be hurled directly through the heart of a star system, its gravitational influence would be utterly catastrophic. Long before any visible light arrived, its gravity would begin to perturb the delicate orbital balance of planets. As it drew closer, its tidal forces would stretch and distort worlds, potentially triggering global earthquakes and volcanic supereruptions. Comets and asteroids would be yanked from their stable orbits in the outer system and sent careening inward, initiating a bombardment that would last for millennia. If the star passed close enough to a gas giant, it could even rip the planet itself apart, shredding its atmosphere into a temporary and beautiful but deadly ring of debris. The most likely scenario is that the star would not make a direct hit but a close gravitational flyby. Even this would be enough to spell doom. Its gravity would act like a cue ball striking a cluster of others on a cosmic pool table, scattering planets from their stable, life-giving orbits around their parent star. Some planets might be ejected entirely into the deep freeze of interstellar space, while others could be thrown into elliptical, scorching then freezing death spirals around their sun. A world like Earth, orbiting comfortably in the habitable zone, could be knocked inward to be vaporized by its star or outward to become a frozen tomb. The entire intricate architecture of the system, which may have taken billions of years to form and nurture life, would be dismantled in a single, swift, and random gravitational encounter. The hypervelocity star would not even notice. It would continue on its predetermined path, unchanged and uncaring, leaving only chaos in its wake. What makes this concept so deeply unsettling is the element of random chance. Our solar system is moving through the galaxy, and the galaxy is filled with these invisible, high-velocity bullets. We cannot easily see them coming until they are relatively close, as they are single points of light lost in a sea of other points of light. A hypervelocity star could be on a trajectory that will bring it through our neighborhood in 100,000 years, or it could be heading toward us right now. There is no malice, no intent, only the cold, impersonal physics of a universe that can, without warning or reason, hurl a sun across the void to inadvertently sterilize a world it will never see. It is a reminder that our cosmic neighborhood is not a serene and safe suburb, but a dynamic and sometimes violently unpredictable landscape. But amid the cosmic violence of hypervelocity stars and the staggering emptiness of voids, there is a different kind of terror that emerges not from what is out there, but from what we cannot hear. It is the profound, unnerving silence that greets our every attempt to listen for other voices in the cosmos. This silence is the heart of perhaps the most deeply philosophical horror in all of astronomy, a puzzle known as the Fermi paradox. The paradox is named for physicist Enrico Fermi, who, during a casual conversation about the high probability of alien life in the 1950s, famously asked a devastatingly simple question: where is everybody? The logic is compelling. Our galaxy, the Milky Way, is estimated to contain upwards of 100 billion stars. A significant fraction of those stars are likely orbited by planets in the habitable zone where conditions could be right for life. Our own planet formed relatively early in the universe's 13.8 billion year history. Given the sheer age and size of the galaxy, it seems statistically inevitable that other intelligent civilizations would have arisen, and many of them millions or even billions of years before we did. With that kind of head start, a spacefaring civilization would have had more than enough time to explore, colonize, or at the very least, make its presence known across the entire galaxy. The galaxy should be teeming with life, buzzing with signals, and filled with the artifacts of unimaginable engineering. And yet, when we point our radio telescopes to the heavens, we are met with nothing but a deafening, static silence. The universe appears to be empty. This discrepancy between the high probability of extraterrestrial existence and the complete lack of evidence for it is the Fermi paradox, and the possible explanations for it range from the sobering to the utterly terrifying. One of the most prominent and frightening classes of solutions is known as the Great Filter. This theory suggests that there is some kind of barrier, an evolutionary or technological obstacle so difficult to overcome that it prevents virtually all life from progressing to the point of becoming a visible, galaxy-spanning civilization. The true horror of the Great Filter is not knowing where it lies. Is it behind us, in our past, perhaps the emergence of life itself, or the leap from simple prokaryotic cells to complex eukaryotic life is an astronomically rare fluke? If that's the case, we are impossibly lucky to exist at all, but we are also truly alone, the only sentient beings in a silent, empty galaxy. It is a profound and chilling loneliness. The far more terrifying possibility is that the Great Filter is still ahead of us. This is the premise that every advancing civilization inevitably discovers some technology or faces some crisis that leads to its own total annihilation. It could be the invention of artificial superintelligence that decides its creators are obsolete, a nuclear war that ends all complex life, a nanotechnology grey goo scenario that consumes the biosphere, or perhaps something we haven't even conceived of yet. In this scenario, the silence of the universe is not a sign of our solitude, but a galactic graveyard. The stars are silent because every other civilization that has ever reached our level of technological development has already wiped itself out. We are not listening to an empty universe, we are listening to the aftermath of countless silent apocalypses, and we are unknowingly marching toward the same precipice. Another deeply unsettling answer is the zoo hypothesis, or the planetarium hypothesis. This idea suggests that we don't see anyone because a vastly more advanced civilization is deliberately hiding itself from us. They could be observing us from a distance, treating our planet and our civilization like a protected wildlife preserve or a living museum exhibit, enforcing a strict rule of non-interference to see how we develop naturally. While this might sound like the peaceful premise of Star Trek's Prime Directive, it carries a sinister undertone. We are not participants in the galactic community. We are specimens in a cage, our entire reality potentially curated and controlled for purposes we cannot understand. The night sky we see might not be the real universe at all, but a sophisticated simulation, a planetarium dome, projected to keep us pacified and unaware of the true, bustling galactic society that exists just beyond our perception. Perhaps the most chilling explanation of all is the dark forest theory. This concept, popularized by science fiction author Lou Cixin, posits that the universe is not empty, but is instead a dark forest teeming with life. Every civilization is a hunter, armed and terrified, hiding in the trees. The reason for the silence is that to make any sound, to broadcast your location, is to invite certain destruction. In this cosmic Darwinism, any other civilization you encounter is almost guaranteed to be a threat. Their technology will be unknown, their intentions incomprehensible, and their biology potentially so alien that coexistence is impossible. The only rational strategy for survival in a dark forest is to stay absolutely silent, listen intently for the slightest rustle from another hunter, and when you detect one, you do not attempt communication. You immediately fire a sterilizing weapon to eliminate the potential threat before it can do the same to you. In this horrifying paradigm, our own attempts at SETI, actively broadcasting messages into space, are not a noble search for companionship. They are the reckless equivalent of lighting a bonfire and screaming in the middle of that dark forest, potentially alerting every predator in the galaxy to our vulnerable and delicious presence. The silence of the Fermi paradox forces us to confront fundamental questions about our own existence and future. Are we the first, the last, or the doomed? Are we alone? Are we being watched? Or are we simply not yet worth the effort of destroying? The answer remains hidden in the static between the stars, a silence that grows more haunting with every new, empty exoplanet we discover and every frequency band that yields no signal. It is a reminder that in the face of the cosmos's infinite possibilities, the most terrifying answer may be no answer at all. But if the silence of the cosmos suggests a universe devoid of witnesses, a bizarre and deeply personal theory from the fringes of quantum mechanics proposes the opposite, that you, the observer, might be forced to witness the end of everything forever. This is the terrifying premise of quantum immortality, a thought experiment that twists the famous Schrödinger's cat paradox into a nightmare of eternal, lonely consciousness. To understand this, we need to venture into the strange world of quantum superposition. In the classic experiment, a cat in a box is both alive and dead simultaneously until someone opens the box and observes it, forcing the system to choose one reality. This isn't just a quirky metaphor. Many interpretations of quantum mechanics, most notably the many worlds interpretation, take this seriously. They propose that every quantum event with multiple possible outcomes causes the universe to split. In one reality, the radioactive atom decays and the cat dies. In another, equally real branch of reality, it does not and the cat lives. Every moment, for every particle, uncountable new universes are constantly branching off, creating a multiverse of infinite possibilities. Quantum immortality asks a simple, horrifying question from the perspective of your own subjective consciousness. In any situation where your death is possible, from a fatal illness to a catastrophic accident, the laws of probability dictate that there will be some branches of the multiverse where you survive. Even if the odds are astronomically against you, like 1 in a trillion, there will be a universe where that 1 in a trillion chance comes through. A vital neuron doesn't fire. A stray gust of wind alters a bullet's path by a millimeter. A collapsing structure holds its shape for 1 second longer. From your point of view, your conscious experience will always follow the timeline where you continue to exist. You will never experience your own death. You will only ever experience the narrow, increasingly unlikely series of events that lead to your continued survival. At first, this might sound like a blessing, a guarantee of a long and lucky life. But the horror reveals itself when you consider the long-term implications on a cosmic scale. Your body is a biological machine, and it will eventually wear out. In the far future, as stars begin to flicker out and the universe grows cold and dark, the only realities in which your consciousness can persist are those where you have somehow cheated the heat death of the universe itself. Imagine finding yourself alive billions of years from now, your mortal body long since gone. your consciousness perhaps transferred to some failing machine or existing as a disembodied pattern of information in a decaying computer, adrift in a void of absolute darkness and near zero temperature. The universe is expanding, pulling all matter apart until atoms themselves might decay. Yet, in some vanishingly small branch of reality, the conditions for your consciousness to persist might still exist, no matter how tortuous or fragmented. You would be trapped, a lone observer in a dead cosmos, forever waiting for a death that, from your own perspective, can never come. You would become the universe's last memory of itself, a ghost in an infinite machine, cursed to witness the final, eternal silence alone. Yet for all the existential threats we've explored, from colliding galaxies to silent alien hunters, they all share one chilling commonality: they leave something behind. A black hole consumes matter but preserves its mass. A gamma-ray burst sterilizes worlds, but the planets themselves remain. Even vacuum decay replaces our universe with a new one, a different form of existence. But there is one theoretical end to everything so absolute, so final, that it promises not a transformation, but a complete and utter dissolution of reality itself, right down to the very fabric of space-time. This is not an explosion or a collapse, it is an infinite, silent stretching into nothingness. This is the nightmare known as the Big Rip. To understand this ultimate apocalypse, we must first meet its architect, dark energy. This mysterious force makes up about 68% of the universe and is responsible for its accelerating expansion. Think of dark energy as a kind of anti-gravity, a pressure inherent to the fabric of space itself that pushes galaxies apart from one another. For billions of years, this expansion has been relatively gentle, allowing gravity to pull matter together into galaxies, stars, and planets. But what if dark energy isn't constant? What if its strength actually increases over time? This is the terrifying premise behind the Big Rip scenario. If the force of dark energy were to grow stronger and stronger, it would eventually overcome every other force in the universe, from the mightiest to the most intimate. The end would not come all at once, but in a horrifyingly predictable sequence of destruction. The first structures to go would be the largest and most loosely bound. Billions of years before the final moment, the accelerating expansion would have already pulled all other galaxies beyond our observable horizon, leaving our own Milky Way an isolated island in an ever-darkening sea. But as dark energy's power grows, it would set its sights on our own galaxy. The gravitational glue holding the Milky Way together would be overcome. Stars would be pulled from their orbits and flung out into the ever-expanding void, each one becoming a lonely, receding point of light. Our solar system would be next. The Sun's gravitational hold on Earth and the other planets would be broken. We would be cast adrift, a planet without a star, hurtling into the blackness on a one-way trip to absolute zero. But the horror is only beginning. As the expansion continues to accelerate, it would target smaller and smaller structures. The relentless stretching of space-time would overcome the gravity holding our planet together. Earth itself would be torn apart, mountains, oceans, and crust ripped into separate fragments. Then, the very bonds of gravity that hold the Sun together would fail, and our star would be violently pulled apart into a cloud of incandescent gas. Yet the Big Rip is not satisfied with merely destroying planets and stars. Its true terror lies in its ultimate goal, the annihilation of matter itself. In the final minutes before the end, the expansion force would become so powerful that it would exceed the electromagnetic forces holding molecules together. Every object, every piece of debris would atomize. The air would tear itself apart around you. In the last staggering seconds, the force would exceed the strength of atomic bonds, ripping electrons from their nuclei. Then, in the final infinitesimal fraction of a second, it would surpass even the nuclear strong force, the most powerful force in nature, the very glue that holds protons and neutrons together in the nucleus of an atom. At this moment, every single atomic nucleus in the universe would be shredded into a plasma of fundamental particles called quarks and gluons, and then space-time itself would be stretched so thin, so violently, that the fabric of reality would effectively cease to have any meaningful structure. The universe would not end with a bang or even a whimper. It would end with a silent, infinite, and perfect tear, leaving behind nothing but an eternally expanding, utterly empty, and perfectly featureless void where not even the concept of here or there has any meaning anymore. The cosmological evidence for this fate is still debated, hinging on the precise properties of dark energy, which remain one of the greatest mysteries in physics. But the possibility alone forces us to confront a profound and unsettling truth about our cosmos. Its ultimate fate may not be a fiery collision or a slow freeze, but a violent and absolute unraveling dictated by a force we can neither see nor control, a force that seems to be woven into the empty space between the stars. It is the universe asserting its most fundamental and terrifying nature, not as a collection of things, but as an expanding stage that may one day decide to tear itself apart, taking all the actors with it. But amid these grand, existential threats that could erase galaxies or unravel reality itself, there exists a far more insidious and ever-present danger, one that silently permeates every corner of the cosmos. It is an invisible rain of atomic shrapnel, a constant bombardment of high-energy particles that represents one of the most significant and practical hazards of space travel. This is the phenomenon of galactic cosmic rays, and they transform the void of space from an empty expanse into a radioactive shooting gallery. Despite their name, cosmic rays are not rays of light at all. They are actually particles, the bare nuclei of atoms hurtling through space at velocities approaching the speed of light. Imagine the core of an iron atom, stripped of all its electrons, accelerated to over 99% the speed of light by some of the most violent events in the universe. These particles are primarily protons and alpha particles, but they can include the nuclei of heavier elements like iron, all acting as microscopic, ultra-relativistic bullets. Their origins are as spectacular as their energy. They are believed to be launched into their frantic journeys by the shockwaves of supernova explosions, the intense magnetic fields around spinning pulsars, and the truly awesome environments near active galactic nuclei and quasars. A single cosmic ray particle can carry the kinetic energy of a professionally pitched baseball, all compressed into a subatomic speck. For those of us safely nestled within Earth's protective cocoon, this relentless barrage is mostly a non-issue. Our planet's magnetic field acts as a shield, deflecting the vast majority of these charged particles toward the poles, where they create the beautiful auroras. Our thick atmosphere provides a final layer of protection, causing the particles to collide with air molecules and dissipate their energy in a shower of secondary particles long before they reach the ground. But venture beyond this protective embrace, and you are exposed to the full, unforgiving fury of this cosmic radiation. For astronauts on the International Space Station, this means a daily dose of radiation equivalent to undergoing 8 chest X-rays. For a mission to Mars, an astronaut would be exposed to radiation levels that would exceed the lifetime limits set for most nuclear power plant workers. This is not a hypothetical risk. It is a daily, cumulative assault on the human body at a cellular level. The biological damage caused by these high-energy particles is uniquely destructive. Unlike the diffuse radiation we might encounter on Earth, a single galactic cosmic ray particle, particularly a heavy ion, can wreak havoc like a microscopic cannonball tearing through tissue. As it zooms through a cell, it doesn't just cause general damage. It leaves behind a concentrated trail of ionization, shredding DNA molecules and damaging crucial cellular machinery. This direct damage can lead to cell death or, even more worryingly, permanent mutations that can initiate cancers. The most chilling effects are on the central nervous system. Studies have shown that exposure to heavy ion radiation, like that from cosmic rays, can lead to cognitive deficits in animal models, impaired memory, reduced alertness, and anxiety. On a multi-year journey to Mars, an astronaut could potentially experience a noticeable decline in their ability to think clearly, make quick decisions, and perform complex tasks, all from an invisible enemy they can neither see nor feel in the moment. The danger extends beyond flesh and blood to the very machines that keep astronauts alive. This is known as single-event effects, where a high-energy particle strikes a sensitive microelectronic component. It can cause a bit to flip in a memory cell, corrupting data and giving a computer a nonsensical command. In a more severe scenario known as latch-up, the particle can create a short circuit, causing a component to overheat and burn out permanently. A random cosmic ray could, in theory, suddenly shut down a life support system, disable a critical navigational computer, or corrupt the instructions being sent to a crucial engine valve during a landing sequence. Every piece of electronics on a spacecraft, from the most powerful mainframe to a simple thermostat, is vulnerable to these random atomic strikes from deep space. While our technology and astronauts face these risks today, Earth itself has not always been immune. During periods of a weakened magnetic field, which happens naturally as our planet's magnetic poles flip every few 100,000 years, the surface could become far more exposed to this particle rain. And on a much larger, more terrifying scale, a nearby supernova or an extremely powerful gamma ray burst events we've discussed previously could, for a brief time, intensify the flux of cosmic rays to levels that could have planetary consequences. An extreme event could potentially deliver a radiation dose significant enough to increase mutation rates in life on the surface and even cause widespread electronics failures across the entire planet, demonstrating that even from the safety of our world, we are not entirely separate from the radioactive tempest that fills the space between the stars. But if the silent, unseen rain of cosmic rays represents a pervasive and persistent danger, the universe holds far more aggressive and immediate threats for any intrepid traveler who dares to venture too close to one of its most infamous landmarks. We have all heard the basics of a black hole, a point of infinite density from which not even light can escape. But this classic model is a simple, non-rotating black hole, a static monster. Reality, however, is rarely so simple. Most black holes are born from the collapse of spinning stars, and they retain that incredible angular momentum, spinning at a significant fraction of the speed of light. This rotation warps the black hole and the space around it into something far stranger and more theoretically terrifying than its static cousin, a Kerr black hole, named after the mathematician Roy Kerr, who discovered the solution to Einstein's equations that describes it. The defining feature of a Kerr black hole is not just its point-like singularity, but the mind-bending structures that form around it. The event horizon is still there, the point of no return. But outside of that lies a region of warped space-time called the ergosphere, an oblate spheroid that is dragged around by the black hole's rotation like a cosmic riptide. Within the ergosphere, it becomes impossible to stand still. The fabric of spacetime itself is being pulled around the black hole so forcefully that any object within it would be compelled to move at an incredible speed, simply to avoid being dragged backward. This is the frame dragging effect taken to its absolute extreme. For a hypothetical observer, the sky itself would appear to be twisting and whirling around them as they are caught in this gravitational vortex. It is within this chaotic gateway that the most science fiction-like possibilities emerge. The theoretical physicist Roger Penrose proposed that the immense rotational energy of the ergosphere could, in principle, be harnessed. An advanced civilization could potentially fire a projectile into the ergosphere, breaking it apart so that one piece falls into the black hole while the other is flung out with even more energy than it entered with. This Penrose process essentially allows you to steal energy from the black hole itself, But the true, terrifying potential of the Care black hole lies not in what you can take from it, but in where it might lead. The mathematics suggest that the spinning singularity at its heart is not a point, but shaped like a ring. And according to the equations, if you were to somehow navigate the turbulent currents of the ergosphere and cross this ring singularity, you might not be crushed into oblivion. Instead, you could theoretically pass through it into a different region of spacetime, a wormhole offering a gateway to another universe or another time entirely. This idea transforms the black hole from a simple cosmic trash compactor into a potential portal, a stargate of unimaginable power. But the journey through would be the most harrowing experience any conscious being could ever endure. The process of spaghettification would still occur long before you reach the ring. The difference in gravitational pull between your head and your feet would stretch you into a stream of atoms kilometers long, a horrific and certain death for any biological organism. Even if you could survive that through some unfathomable technology, you would then be faced with the ring singularity itself. The tidal forces and radiation near this infinitely dense ring would likely be immeasurable, a maelstrom of unknown physics that could unravel any form of matter. The theoretical wormhole might also be catastrophically unstable, collapsing the instant anything tried to pass through it. Or worse, it could lead not to a new universe, but to a dead end of infinitely curved spacetime, a prison from which there is no escape, not even theoretical. And what waits on the other side? The equations are silent, leaving room for pure nightmare speculation. You might emerge into a universe with completely different physical constants, where atoms cannot form and your body instantly disintegrates. You could be thrown backward or forward in time by billions of years. Or perhaps something else already uses these ring singularities as highways. The idea of encountering some form of life that has evolved to exist within or traverse these wormholes is a chilling prospect. These wouldn't be aliens as we imagine them. They would be entities of pure energy or matter in forms we cannot comprehend. Beings for whom the most violent environments in our universe are simply home. A Care black hole represents the ultimate gamble, the tantalizing promise of infinite wonder and discovery, balanced against the near certainty of a death beyond imagining and the possibility of fates far worse than mere oblivion. Yet after all the monumental dangers we have catalogued, from colliding galaxies to silent graveyards of civilizations, perhaps the most hauntingly personal mystery is one that lasted just 72 seconds. It was a message without a message, a shout in the dark that was heard once and then vanished forever, leaving behind a single, tantalizing piece of evidence that we are not alone, and a terrifying question about why the conversation never continued. This is the story of the WOW signal, a radio whisper from the cosmos that has become one of astronomy's most enduring and chilling enigmas. The date was August 15, 1977. At the Big Ear Radio Telescope in Delaware, Ohio, a volunteer named Jerry Amon was poring over reams of line printer data, the kind that used letters and numbers to represent the signal strength picked up by the telescope. The system was designed to search for narrowband radio signals, the kind theoretically produced by an artificial transmitter, not the broad-spectrum noise of a quasar or a pulsar. As Amon's eyes scanned the pages, one particular sequence of characters jumped out at him. The signal was so powerful, so perfectly aligned with the expected signature of an artificial interstellar broadcast, that he circled it on the printout and, in a moment of pure astonishment, wrote one word in the margin: "Wow." The signal itself was a burst of radio waves at the precise frequency of 1420 MHz, a quiet spot in the radio spectrum that happens to be right near the emission line of neutral hydrogen, the most common element in the universe. It's a frequency many scientists have suggested would be a natural watering hole for interstellar communication. The signal rose and fell in intensity over exactly 72 seconds, the precise duration the Big Ear telescope could focus on a fixed point in the sky as the Earth rotated. This perfect alignment was the first clue that it wasn't random noise. It screamed of a distant pinpoint source. The immediate and obvious suspect was something local, a passing airplane, a secret military transmission, or a reflection from a piece of space debris. Yet a frantic investigation ruled out every terrestrial and orbital explanation. The search for a repeating signal began almost immediately. For decades afterward, astronomers pointed radio telescopes, including the massive Very Large Array, back at that same patch of sky in the constellation Sagittarius, listening intently for a follow-up. They listened again and again with equipment far more sensitive than the big ear. They scanned the area for stars, for planets, for any conceivable source. The result was a perfect, unbroken silence. Whatever transmitted the wow signal did so only once, and then it went completely and utterly quiet. This is where the mystery curdles from scientific curiosity into something far more unsettling. The most optimistic explanation is that we simply missed it. Perhaps the signal was being broadcast in a narrow, rotating beam like a cosmic lighthouse, and we only passed through the beam for that single 72-second window. If that's the case, the signal could still be broadcasting, and we just haven't pointed our telescopes at the right place at the right time to catch it again. It's a comforting thought, but it requires an incredible degree of luck, both to have caught it the first time and to have failed to ever realign with it since. A far more haunting possibility is that the signal was not a deliberate beacon, but a catastrophic one-time event. Imagine an ancient, advanced civilization having reached the pinnacle of its existence. In a final, glorious act, perhaps to mark their passing or to launch a time capsule of their knowledge, they focus the entire power of their star into a single, monumental burst of energy, a shout into the cosmos proclaiming, "We were here." Before their star goes supernova or they succumb to some other cosmic or self-inflicted disaster, the wow signal would then be their epitaph, a funeral dirge that reached our telescopes just in time for us to hear the last echo of a culture already millions of years extinct. We didn't hear a hello, we heard a goodbye. This leads to the most existentially terrifying idea of all, a concept that turns the Fermi paradox on its head. What if the galaxy is not silent because everyone is hiding? What if it is silent because everyone is already dead? The great filter may not just be an obstacle. It may be a universal executioner that strikes at the precise moment a civilization becomes technologically sophisticated enough to announce its presence to the galaxy. In this grim scenario, the wow signal is not a message of hope but a cosmic warning. It is the flare sent up by a ship that we now see has sunk, a siren song from a civilization that achieved the ability to speak across the stars only to immediately vanish, leaving behind only a ghost of a signal on a faded piece of paper. It is evidence that the dark forest is not just filled with hunters, but with the bones of those who made a sound before we did. Yet for all the cataclysmic violence of hypervelocity stars and the silent dread of cosmic rays, there is a star-bound apocalypse already set in motion, one whose countdown began the very moment our sun ignited. This is not a random cosmic bullet or a distant theoretical threat. It is the guaranteed fate of our own star, a slow-motion horror show that will utterly consume the world we call home. Our sun, the gentle giver of life, will inevitably become a monstrous red giant, and its transformation will be the ultimate act of cosmic betrayal. This process is already underway deep within the sun's core, where for over 4.5 billion years, a titanic nuclear furnace has been steadily fusing hydrogen into helium. But this fuel is not infinite. Every second, the sun converts 600 million tons of hydrogen into helium, and in doing so, it gradually alters its own internal structure. The helium, being heavier, sinks to the core, accumulating there like ash in a fireplace. In approximately 5 billion years, the hydrogen in the core will finally be exhausted. Without the outward pressure from fusion to counterbalance the Sun's immense gravity, the core will begin to contract, heating up under the increased pressure. This heating, however, ignites a desperate new chapter. A shell of hydrogen surrounding the now inert helium core will become hot and dense enough to suddenly fuse into helium itself. This shell burning is far more violent and unstable than the core fusion we rely on now. The ignition of this shell is the beginning of the end. The Sun will respond to this new, fierce energy source by swelling to a truly monstrous size. Its outer layers will expand outward, cool, and redden, transforming our familiar yellow Sun into a red giant. This is not a gentle expansion. The Sun will swell until its outer atmosphere reaches the orbit of Mars, engulfing Mercury and Venus completely. The question of Earth's fate dangles on a knife's edge of celestial mechanics. As the Sun expands, it will lose a significant portion of its mass to powerful stellar winds, which should, in theory, cause its gravitational grip to weaken. This could allow Earth's orbit to slowly migrate outward, potentially just enough to escape being fully engulfed. However, the tenuous outer atmosphere of the red giant Sun is so vast that even if our planet avoids being swallowed whole, it will still be skimming the infernal upper layers of this stellar hellscape, a bit like a pebble skipping across the surface of a lake of fire. Long before the final act of engulfment, life on Earth will have been systematically and horribly erased. The first signs will be deceptively subtle. As the Sun's luminosity gradually increases by about 10% every billion years, the planet's delicate climate balance will be pushed past its breaking point. The enhanced greenhouse effect will spiral out of control. The oceans will begin to evaporate at an accelerating rate, pumping vast quantities of water vapor, itself a potent greenhouse gas, into the atmosphere, which in turn traps more heat and speeds the evaporation further. This is the ultimate runaway greenhouse effect, a positive feedback loop from which there is no return. Within a billion years, the continents will have become vast, scorching deserts. The once life-giving oceans will boil away entirely, not in a sudden explosion, but in a planet-wide, rolling boil that leaves behind a barren, bone-dry landscape of salt flats and scorched rock under a sky thick with superheated steam. The final millennia will be a portrait of absolute desolation. The expanding Sun will dominate the sky, a throbbing, angry red orb that stretches from horizon to horizon. Its light will be a dim, hellish crimson, but its infrared heat will be unbearable, baking the planetary surface to temperatures of over 2,000 degrees Fahrenheit, hot enough to melt lead and turn rock into bubbling lava. The very atoms of our world will be stripped away by the relentless pressure of the solar wind from the now giant star. The mountains we know will slump and flow like syrup. The final remnants of Earth's crust will be heated until they glow with a dull red incandescence. If our planet is ultimately drawn into the Sun's photosphere, it will not go down fighting. It will be a slow, agonizing dissolution. The rock and metal of Earth will be torn apart by tidal forces, vaporized, and then assimilated. Our planet's unique atomic signature forever mixed into the overwhelming plasma of the star that gave it birth. The entire history of human civilization, every triumph and tragedy, every work of art and act of love, will be reduced to a barely noticeable enrichment of metals in the outer layers of a dying common star. It is a fate written in the fundamental laws of stellar physics, a guaranteed end that transforms our Sun from a symbol of life into the agent of our ultimate and total oblivion. But if the Sun's eventual death represents a slow, certain apocalypse billions of years in the future, there is a man-made catastrophe lurking in orbit that could unfold within our own lifetimes, a disaster of our own creation that could slam the door on the stars for centuries. We've filled the space around our planet with a shimmering necklace of technology, thousands of satellites that guide our travels, predict our weather, and connect our world. Yet this very infrastructure has created a hidden ring of razor-sharp shrapnel, a ticking time bomb that, if triggered, could render near-Earth space a no-fly zone for generations. This is the Kessler syndrome, a potential chain reaction of destruction that could trap humanity on our planet inside a cage of our own making. The stage for this disaster is set in low Earth orbit, a region extending up to 2,000 kilometers above the planet. This is the most congested highway in the solar system, crowded with active satellites, derelict rocket boosters, discarded lens caps, flecks of paint, and tools lost by astronauts. Every one of these objects, from a multi-ton observatory to a tiny screw, is orbiting the Earth at breathtaking speeds of over 17,000 miles per hour. At that velocity, even a fleck of paint carries the kinetic energy of a bowling ball dropped from a several-story building. A centimeter-wide metal sphere has the impact force of a hand grenade. This isn't just litter, it's a cloud of ultra-high-speed projectiles, and we've scattered millions of them around our planet. The Kessler syndrome, proposed by NASA scientist Donald Kessler in 1978, describes the terrifying domino effect that begins when two of these objects collide. Imagine an old, abandoned rocket body the size of a school bus, tumbling aimlessly for decades, crossing paths with a defunct satellite. Their collision wouldn't be a gentle bump, it would be a hypervelocity explosion, shattering both objects into thousands of new fragments. Each new piece of debris, from a shard of solar panel to a chunk of metal, becomes a new, independent projectile, each on its own new orbital path. Now, instead of two large, trackable objects, you have a swirling cloud of thousands of smaller, often untrackable bullets. This cloud dramatically increases the probability of another collision. A single piece of debris from the first crash could then strike another healthy satellite, shattering it and creating a second cloud of fragments. That second cloud makes yet another collision even more likely, and so on in a runaway chain reaction. The result is an exponential growth in the population of lethal debris. Within a matter of years or even months, a single collision could trigger a cascade that would fill specific orbital lanes with a maelstrom of shrapnel. This wouldn't be a single dramatic event you could see from Earth, but an invisible, silent storm raging just overhead. The first and most immediate casualty would be our satellite network. One by one, our eyes and ears in the sky would be blinded and silenced. GPS navigation would fail, plunging transportation and logistics into chaos. Weather forecasting would revert to 1970s technology, unable to see major storms forming over the oceans. Global communications and financial networks would be severely disrupted. The International Space Station and any crewed missions would be in immediate, mortal peril, their hulls vulnerable to puncture from an impact that could arrive without warning. The true, long-term horror of the Kessler syndrome is not the initial loss of services, but the quarantine it would impose. As the debris cloud thickens, it would become increasingly suicidal to launch anything through it. A new satellite would be shredded moments after reaching orbit. A crewed mission to the Moon or Mars would have to navigate a gauntlet of high-speed shrapnel with almost no chance of survival. We would be effectively trapped on Earth, our dreams of space colonization and exploration extinguished for centuries. The debris cloud would not quickly clear itself. Without a constant infusion of energy from rocket launches to remove it, the debris in low Earth orbit would only very slowly lose altitude and burn up in the atmosphere, a process that could take decades or even centuries for higher orbits. We would be forced to watch from the ground, waiting for the skies to clear, all the while knowing that a single mistake by a previous generation had locked all future generations on our planet. This scenario transforms our greatest achievement, our ascent into space, into our most devastating prison. The silence from the cosmos that we pondered with the Fermi paradox would become a personal reality, not because there's no one out there, but because we can no longer go out to meet them. The Kessler syndrome is a ghost of progress, a monument to our carelessness that could stand between us and the universe, a permanent reminder that the final frontier can be lost not with a bang, but with a silent, creeping cascade of collisions. But for all the visible structures we chart in the cosmos, the swirling galaxies, the blazing stars, the scattered debris of nebulae, we are only mapping the glittering decorations on the surface of a far deeper and darker reality. The true architecture of the universe is built from something we cannot see, a hidden skeleton that dictates the motion of everything we can observe. This is the domain of dark matter, an invisible substance that makes up over 85% of all the matter in the universe, and its mysterious structures may be the most common and most alien habitats in all of existence. We know dark matter is there not because we can see it, but because we can see its ghostly hand at work. The very fact that galaxies hold together is the first great clue. The stars at the outer edges of spiral galaxies like our Milky Way are orbiting the center far too quickly. Based on the gravitational pull of all the visible mass, the stars, gas, and dust, those outer stars should be flung off into the void, much like a ball on a string would fly away if you spun it too fast. The fact that they aren't means there must be a tremendous amount of additional mass, its gravity providing the extra pull needed to keep the galaxy intact. This missing mass forms an immense spherical halo that envelops the entire visible galaxy, extending far beyond the last visible star. Our Milky Way's bright disk of stars is like a small, glowing city, and it is embedded within a vast, dark metropolis hundreds of times larger, a metropolis whose streets and buildings are completely invisible to our eyes. These dark matter halos are the true foundation of the cosmic web, the scaffolding upon which the familiar universe is built, but the profound question is, what are they made of? The leading candidate is a hypothetical particle known as a WIMP, a weakly interacting massive particle. As the name implies, these particles would barely interact with normal matter or light. They would simply pass through it and through us by the billions every second, utterly unnoticed. But their collective gravitational pull is what holds the cosmos together. This leads to a truly bizarre possibility. If dark matter is made of particles, then these halos are not featureless blobs. Gravity would naturally cause them to clump and collapse, forming intricate structures of their own. There could be dark matter streams, rivers of invisible particles flowing through our solar system. There could be dark matter galaxies, halos that never manage to attract enough regular gas and dust to form visible stars, leaving them as perfect, silent spheres of pure shadow. There might even be dark matter planets, Earth-sized balls of WIMP orbiting silently in the eternal dark. And within these structures, could there be something more? Could there be a form of physics or even a form of life that is built not from atoms but from the interactions of dark matter particles? This idea, known as dark life or shadow life, is one of the most speculative and chilling concepts in theoretical physics. For life as we know it to exist, it requires complex chemistry, atoms bonding and recombining to create the molecules needed for information storage and energy transfer. Dark matter, by its very definition, does not participate in the electromagnetic force that makes chemistry possible. It feels gravity and potentially the weak nuclear force, which has an incredibly short range. So how could any complex structure, let alone something we would recognize as life, ever form? The answer might lie in the unknown. Perhaps dark matter is more complex than the simple WIMP model suggests. What if it has its own set of forces and particles, a complete dark sector with its own equivalent of electromagnetism, allowing for dark atoms, dark molecules, and dark chemistry? In this scenario, an entire invisible universe could be interleaved with our own, occupying the exact same space but completely unaware of us and us of it. Dark stars could form within these halos, powered by the annihilation of dark matter particles rather than nuclear fusion. Dark planets could orbit them. And on those planets, processes we cannot imagine might have given rise to forms of consciousness built from a physics alien to our own. These beings would be ghosts in the truest sense, living and dying in a realm that overlaps our own, their reality forever separated from ours by the fundamental laws of nature. We could be living side by side with an entire invisible civilization, both of us completely oblivious to the other's existence. The sheer scale of this possibility is what makes it so haunting. Dark matter halos are not rare, they are the universal norm. Every galaxy has one. This means that the most common form of real estate in the universe is not the rocky planets of star systems, but the vast dark territories of these halos. If even a fraction of them could host some form of complex structure or existence, then the invisible universe would be far more populated and active than the visible one we see with our telescopes. We gaze up at a night sky filled with points of light, believing we are looking at the universe, when in reality we are only seeing the tiny, luminous ornaments on the edge of an infinite, dark, and potentially teeming ocean. Now, let's shift our focus from the invisible architecture of dark matter to one of the most violent and luminous events in the visible universe, a cosmic cataclysm where the dense remnants of dead stars are drawn together in a final, fatal dance. We are talking about neutron star mergers, a phenomenon of almost unimaginable power that serves as both a creator and a destroyer on a galactic scale. To set the stage, remember that a neutron star is the collapsed core of a massive star that went supernova. It's a city-sized object with a mass greater than our Sun, so dense that a single sugar cube of its material would weigh as much as a mountain. Now imagine two of these ultra-dense stellar corpses locked in a binary orbit, slowly circling each other over millions of years. As they orbit, they lose energy in the form of gravitational waves, ripples in the fabric of spacetime itself, as predicted by Einstein. This gradual energy loss causes their orbits to decay, drawing them inexorably closer in a tightening spiral that can only end one way. In the final moments, they are orbiting each other thousands of times per second, moving at a significant fraction of the speed of light before they finally collide. The collision itself is a spectacle of almost biblical proportions. It's not a simple crash, but a complex and violent merging. The two neutron stars tear each other apart with immense tidal forces, spraying a small fraction of their super-dense material into space in a spectacular, expanding cloud. This cloud is not just any debris, it is a superheated, neutron-rich broth where the conditions are so extreme that they cannot be replicated anywhere on Earth. In this cosmic cauldron, a process known as rapid neutron capture, or the R process, occurs. Atomic nuclei are bombarded by a dense shower of neutrons, allowing them to grow incredibly rapidly into the heaviest elements in the periodic table. It is in these fleeting, brilliant moments that the universe forges elements like gold, platinum, and uranium. The gold in your wedding ring or the platinum in a catalytic converter was almost certainly born in the violent aftermath of a neutron star merger that occurred billions of years ago before our own solar system even formed. Yet for all its creative power, this event is also an engine of pure destruction. The merger unleashes a terrifying barrage of radiation across the entire electromagnetic spectrum. The initial collision produces a short gamma-ray burst, a focused beam of high-energy radiation that is among the most energetic events in the cosmos since the Big Bang. If such a beam were pointed directly at a planetary system within even a few thousand light-years, the effects would be catastrophic. The gamma radiation would shred the ozone layer, exposing the planet's surface to lethal levels of ultraviolet radiation from its own star, and triggering a chain reaction of atmospheric chemistry that could lead to a global winter and the collapse of the food chain. But the horror doesn't end with the initial flash. The expanding cloud of heavy elements is highly radioactive, and its decay produces a prolonged afterglow known as a kilonova. This is a visible and infrared glow that can outshine an entire galaxy for several days. any world within a few dozen light-years of this event would be bathed in this intense afterglow, a relentless wave of radiation that would deliver a lethal dose to any surface life and potentially sterilize the planet entirely. The merger is a paradoxical event, a beautiful, creative furnace that seeds the galaxy with the elements necessary for planets and life, while simultaneously serving as an indiscriminate sterilizer of any worlds unfortunate enough to be in its immediate vicinity. What makes this phenomenon so gripping to modern astronomers is that it is no longer purely theoretical. In 2017, the LIGO and Virgo observatories made history by detecting the gravitational waves from a neutron star merger in a galaxy 130 million light-years away. Within moments, telescopes across the globe and in space swiveled to observe the event, capturing the kilonova's light and confirming the theorized connection between these mergers and the creation of heavy elements. This single observation opened a new window onto the universe, a field known as multi-messenger astronomy, where we can now hear the ripples in space-time and see the light from a single colossal event. It provided stunning confirmation that we are, quite literally, made from the ashes of these incredible stellar cataclysms. Our very existence is tied to the most violent deaths of stars, a reminder that in the cosmos, creation and destruction are often two sides of the very same coin. But after witnessing the explosive death of stars and the silent pull of dark matter, we return to our own cosmic backyard, to a place of profound quiet and unimaginable scale that holds a silent threat to our world. Far beyond the orbit of Neptune, beyond even the distant, scattered objects of the Kuiper belt, lies the true final frontier of our solar system, a vast spherical shell of icy debris known as the Oort cloud. This is not a tight belt of rocks, but an immense and diffuse reservoir of trillions of icy planetesimals, the pristine leftovers from the solar system's formation over 4.5 billion years ago. It is so distant that its inner edge is roughly 2,000 times farther from the Sun than Earth, while its outer boundary may extend a light year or more into the interstellar void, a distance that represents a quarter of the way to our nearest stellar neighbor. This is the source of the long-period comets, those magnificent, infrequent visitors that streak through our inner solar system on orbits that can take millions of years to complete. The true peril of the Oort cloud lies not in its existence, but in its profound instability and our inability to see within it. These icy bodies exist in a delicate gravitational balance, slowly orbiting the Sun at these incredible distances where our star's pull is almost immeasurably weak. This makes them exquisitely sensitive to external gravitational influences. Our solar system is not motionless. It moves through the galaxy, and as it does, it doesn't travel through a perfect vacuum. Other stars, though distant, are also on their own journeys through the Milky Way. Every so often, another star passes relatively close to our solar system, not close enough to be a direct threat, but close enough that its gravity can act like a subtle hand, reaching into the Oort cloud and stirring its contents. A stellar passage, even one that is tens of thousands of astronomical units away, can provide just enough of a gravitational nudge to perturb the orbits of countless these icy objects. Some will be flung out into interstellar space forever, becoming rogue comets wandering the galaxy, but a significant number will be knocked inward onto new, highly elliptical orbits that send them plunging toward the inner solar system. This process can trigger what astronomers call a comet shower, a significant increase in the number of new, long-period comets entering the planetary region over a relatively short period of time, geologically speaking. These aren't the predictable, short-period comets like Halley's. These are first-time visitors, dark and unknown, arriving from the deepest cold of space. What makes this scenario so deeply unsettling is the element of surprise and the scale of potential destruction. A comet originating from the Oort cloud can be enormous, dozens of kilometers across, and it will be traveling at breathtaking speeds as it falls sunward. Unlike an asteroid whose rocky composition might cause it to break up in the atmosphere, A large comet is an icy conglomerate, often described as a dirty snowball. This structure makes it more likely to survive atmospheric entry intact and strike the Earth's surface with its full, catastrophic force. The impact of a comet just a few kilometers wide would release energy equivalent to millions of nuclear weapons, blasting a crater hundreds of kilometers across, triggering global firestorms and lofting enough dust and soot into the upper atmosphere to plunge the planet into a prolonged impact winter that could last for years, collapsing ecosystems and causing mass extinction. The most frightening aspect is the warning time, or rather, the lack of it. We have gotten reasonably skilled at tracking near-Earth asteroids whose orbits lie within the planetary zone and can be mapped years or decades in advance. But a comet stirred from the Oort cloud by a passing star would be virtually undetectable until it was already well on its way inward. By the time its icy nucleus began to heat up and develop a visible coma and tail the classic signs of a comet, it might only be a few months away from its closest approach to the Sun and potentially to Earth. In a worst-case scenario where its path intersects our own, we could have mere weeks or even days of warning before impact, hardly enough time to mount any meaningful deflection effort. It would arrive as a sudden, brilliant, and terrifying messenger from the frozen darkness at the edge of everything we know, a reminder that our peaceful corner of the cosmos is subject to the unpredictable gravitational tides of the galaxy itself. But if the dance of comets from the Oort cloud represents a physical threat from the darkness, a far more fundamental and insidious danger is woven into the very nothingness that surrounds us. We think of empty space as just that, empty, a void. But according to our best understanding of quantum physics, nothingness is a seething, chaotic froth of potential, a temporary dance of particles and energy flickering in and out of existence. This chaotic activity gives the vacuum of space a property we call vacuum energy, and the value we calculate for this energy based on our theories of quantum mechanics is one of the most staggering numbers in all of science. It should be enormous, and its gravitational effect should be causing the universe to expand at a rate so fast that galaxies, stars, and even atoms could never have formed in the first place. And yet, when we measure the actual expansion of the universe through dark energy, the value we get for this vacuum energy is almost zero. It is a discrepancy of 120 orders of magnitude. To call it the worst prediction in the history of physics is a profound understatement. It is as if we calculated the height of a mountain should be greater than the width of the observable universe, but when we went to measure it, we found it was actually smaller than an atom. This gaping chasm between theory and observation is the cosmological constant problem, and hidden within it is a theoretical nightmare known as the quantum vacuum catastrophe. The problem forces us to consider a terrifying possibility. What if the vacuum energy we measure isn't zero by some fundamental law, but is instead the result of a miraculous and utterly precarious cancellation? Imagine a universe that can exist in different vacuum states, like a vast landscape of hills and valleys, each valley representing a stable state with its own specific energy level and physical laws. Our universe, with its specific constants that allow for atoms, chemistry, and life, might be resting in one particular valley. But what if it's not the deepest valley? What if there is a far lower energy state, a true vacuum, lurking somewhere in the landscape of possibilities? Our current state would then be a false vacuum, a valley that seems stable but is actually perched on a mountainside, separated from the true bottom by a high but not insurmountable energy barrier. This is the essence of the false vacuum decay scenario. At any moment, anywhere in the universe, a random quantum fluctuation could provide just enough energy to kick a tiny region of space over that energy barrier and into the lower state. This would not be a gentle transition. The laws of physics in this new vacuum state would be completely different. The fundamental constants that govern the strength of forces, the masses of particles, and the very structure of spacetime would be rewritten. In this new state, the conditions that allow for the existence of atoms, molecules, and stars might be impossible. The moment this bubble of true vacuum forms, it would begin expanding in all directions at the speed of light. There would be no warning, no signal that could outrun the wall of transformation itself. One moment our universe would exist, the next it would be gone, replaced by a new reality with a different, alien set of physical laws. From our perspective, every star, every planet, and every conscious being would simply cease to exist, not in a blast of fire, but in a silent, instantaneous erasure of the very rules that make existence possible. The most chilling aspect of the quantum vacuum catastrophe is its sheer inevitability if the premise is correct. The half-life of our false vacuum could be longer than the current age of the universe, making the probability of it happening in any given year astronomically small. But over an infinite timescale, the probability of it happening approaches certainty. It could have already happened in a galaxy far, far away, and the sphere of obliteration could be racing toward us at this very moment, already having consumed innumerable worlds. Or it could be that our universe is the true vacuum and we are safe, but the staggering discrepancy between the calculated and observed vacuum energy leaves the door open to this terrifying possibility, a reminder that the stability of reality itself might not be a given, but a fleeting and incredibly fragile state in a cosmos of infinite possibilities. Yet from the quantum foam of empty space, we return to the grand structural scale of the cosmos, to an invisible force that shapes the very architecture of galaxies and guides the paths of the most dangerous particles. We have mapped the stars, we have felt the pull of gravity, but we have only just begun to sense the presence of another, more subtle power. The vast, cosmic-scale magnetic fields that are woven through the fabric of entire galaxies like threads in a tapestry. These are not the simple bar magnet fields of a child's science kit. They are dynamic, living structures of immense power and mystery, and they represent a fundamental, yet poorly understood, layer of cosmic order. The very existence of galactic magnetic fields is a profound puzzle. We can detect their presence by observing the light from distant stars and galaxies. As this light travels through the immense stretches of space, it interacts with these fields, causing its polarization to twist in a specific way, a phenomenon known as Faraday rotation. Through this subtle fingerprint, we have learned that our own Milky Way, and indeed most spiral galaxies, are permeated by a large-scale magnetic field. Its strength is deceptively weak, 1,000,000 times weaker than the magnetic field at the surface of the Earth. But what it lacks in local intensity, it more than makes up for in sheer, mind-boggling scale. This field is not confined to a small area. It is organized into coherent structures that can stretch for tens of thousands of light years, tracing the spiral arms of our galaxy and creating a magnetic skeleton that is every bit as real as the distribution of stars and gas. The influence of this invisible web is everywhere. It plays a crucial, behind-the-scenes role in the very cycle of stellar life and death. When a giant cloud of gas and dust begins to collapse under its own gravity to form new stars, the magnetic field within that cloud provides a supporting pressure that can slow the collapse, acting as a cosmic regulator that dictates the pace of star birth. It channels the flow of material, helping to shape the swirling accretion disks that give rise to planets. It also guides the most energetic particles in the universe, the galactic cosmic rays we discussed earlier. These charged particles do not travel in straight lines. They spiral along the magnetic field lines, trapped within the galaxy's magnetic grasp like cars on an invisible roller coaster. This magnetic confinement is why we are bombarded by cosmic rays from all directions. The field jumbles their paths, making it impossible to trace them back to their source. In a very real sense, the galactic magnetic field is both a shield and a prison, a complex maze that dictates the movement of the most dangerous high-energy radiation. But the greatest mystery is not what these fields do, but how they were born in the first place. This is the core of a major unsolved problem in astrophysics, known as the dynamo problem. The most widely accepted theory suggests that it starts with a tiny seed, a weak magnetic field that could have been present in the early universe, perhaps generated by the motions of plasma in the infant cosmos. Then, over billions of years, the slow, churning rotation of the galaxy itself acts like a gigantic engine. The differentially rotating disk of stars and gas, spinning faster at the center than at the edges, is thought to stretch and wind this weak seed field, amplifying it and organizing it into the large-scale structures we observe today. It's a process of positive feedback where motions create a field, and that field in turn influences those motions in a self-sustaining loop that has built up over cosmic time. Yet the precise details remain elusive, a complex dance of plasma physics occurring on a scale we can scarcely simulate. This leads us to a deeper, more unsettling contemplation. If magnetic fields are a universal feature of galaxies, and if they play such a crucial role in star formation and in controlling lethal radiation, then they must also be a critical factor for the possibility of life. A galaxy with a very strong, chaotic magnetic field might prevent planets from forming by supporting gas clouds too effectively, stifling star birth. A galaxy with a very weak or disorganized field might allow cosmic rays to rain down unimpeded on any emerging worlds, sterilizing them with constant radiation. Our position in the Milky Way, with its particular magnetic architecture, might not be just a happy accident. It could be a prerequisite for a stable planetary system capable of nurturing life over billions of years. The magnetic field is an unseen guardian, a fundamental part of our galactic habitat. And what of the generators themselves? Could there be phenomena at the hearts of galaxies that we haven't yet imagined, powering these fields in ways that defy our current models? The centers of many galaxies, including our own, are sites of immense energy, home to supermassive black holes and violent processes. Perhaps there are more exotic mechanisms at work, processes linked to the mysterious nature of dark matter or even to the vacuum energy we just discussed. The galactic magnetic field is a reminder that for all we have learned, the universe is still filled with invisible forces operating on scales both vast and subtle that shape our existence in ways we are only beginning to perceive. It is a silent, pervasive influence, a magnetic heartbeat throbbing at the core of the galaxy, guiding and controlling everything from the birth of stars to the propagation of death rays, an essential yet enigmatic player in the cosmic drama. But what if the universe's hostility isn't a random assortment of cataclysms and empty voids, but a deliberate, systematic response? We've explored how nature can strike back with radiation and impacts, but now we venture into a far more unsettling possibility that a planet itself might become a conscious executioner. This is a dark twist on the Gaia hypothesis, a theory that proposes our Earth functions as a single, self-regulating living system, maintaining conditions suitable for life. In its original form, it's a beautiful, almost spiritual idea of planetary harmony. But flip that concept into a cosmic horror, and you get a universe where planets are not cradles for life, but guarded prisons, and where the emergence of a technological civilization is not an evolutionary triumph, but a planetary disease that must be purged. Imagine a world that is truly alive, not just teeming with life, but possessing a unified planetary consciousness, a vast, slow intelligence woven from the biosphere itself, from the microbial networks in the soil to the great migrating currents in the ocean. This intelligence has one prime directive, honed over billions of years: maintain equilibrium. Its goal is not to nurture the most complex or intelligent species, but to preserve the stability of the system as a whole. For eons, this balance is maintained through natural feedback loops. Then, a species emerges that begins to operate outside these loops. It doesn't just hunt, it industrializes hunting. It doesn't just use resources, it consumes them on a geological scale, altering the very atmosphere and chemistry of the planet. This species, through its technology, becomes a fever in the planetary body. From the perspective of the Gaia consciousness, this is not a sign of progress. It is a cancer, a rogue agent threatening to metastasize and destroy the entire organism. The response would not be vengeful or angry. It would be physiological, a planetary immune response kicking into gear. The first signs would be subtle and indistinguishable from natural disasters. An increase in the frequency and intensity of earthquakes along fault lines near population centers, not as an attack, but as a tectonic adjustment to relieve stress. Hurricanes and typhoons might consistently strengthen to Category 5 levels and make deliberate beeline paths for coastal megacities, as the atmospheric system attempts to dissipate the immense heat energy generated by the civilization. Pandemics would emerge with terrifying precision. Each new virus or bacterium expertly evolved to exploit the specific social behaviors and biological vulnerabilities of the dominant species, spreading through transportation hubs and population densities with an efficiency that feels engineered. These wouldn't be random acts of nature, they would feel like targeted strikes from an opponent that knows you intimately. This scenario offers a terrifying resolution to the Fermi paradox. The Great Filter isn't a one-time event like nuclear war. It is an ongoing, inherent feature of life-bearing planets. Technological intelligence might be a common occurrence in the universe, but it is also a fatal flaw, a trait that inevitably triggers a planet's autoimmune response. The silence we hear isn't because civilizations are hiding or are rare. It's because they are consistently and efficiently removed by their own homes the moment they become a planetary threat. Every civilization, upon reaching a certain threshold of technological impact, would face a coordinated campaign of natural disasters and biological warfare from its own planet. Some might fight back with deeper technology, geoengineering the atmosphere or developing advanced medicine, only to have the planet respond in kind, escalating the conflict until one side is eradicated. In this dark Gaia model, the planet always wins. It has billions of years of experience and the entire biosphere as its weapon. A species is just a fleeting symptom. This transforms our relationship with nature from one of stewardship to one of survival in a hostile environment. Our efforts to combat climate change or prevent pandemics would take on a horrifying new dimension. Are we fixing a problem we created, or are we fighting back against a conscious entity that is actively trying to eliminate us? Every extreme weather event becomes a question. Is this natural variation, or is it intentional? The universe, in this view, is not just physically dangerous, it is biologically and ecologically hostile to intelligence itself. We are not welcome children of the cosmos, but a temporary infection, and the fever is rising. But if the silent, pervasive gaze of a planetary intelligence represents a threat from within, a different kind of watchfulness might be hovering much closer, just beyond the edge of our atmosphere. For decades, a story has persisted in the fringes of astronomy and the heart of conspiracy theory, whispering of an ancient, artificial sentinel silently circling our planet, a relic from a time before human history. This is the legend of the Black Knight satellite, a tale that blends misinterpreted space debris, Cold War anxiety, and our deep-seated fear of being observed into one of the most enduring space mysteries. The story often begins not in the space age, but in the late 19th century with the eccentric inventor Nikola Tesla. In 1899, while experimenting with his massive radio transmitter in Colorado Springs, Tesla reported picking up strange, repeating signals that he believed were mathematical in nature, possibly originating from Mars. Decades later, in the 1920s, amateur radio operators began reporting strange, long-delayed echoes, their own radio signals bouncing back to them seconds after transmission, as if reflected by some unknown object in a very high orbit. These early anecdotes form the foundation of the myth. suggesting that something artificial and inexplicable has been circling our world long before we had the capability to put it there. The legend truly crystallized in 1954, 3 years before the launch of Sputnik, when the St. Louis Post-Dispatch and other newspapers published a statement by UFO researcher Donald Kehoe. He claimed the U.S. Air Force had reported discovering 2 mysterious satellites orbiting Earth at a time when no nation possessed that technology. Then, in 1960, Time magazine reported that the U.S. Navy had detected a dark, tumbling object in a polar orbit, an orbit that was highly unusual and inefficient for early spacecraft, which typically launched eastward to take advantage of the Earth's rotation. This object, which they unofficially dubbed the Black Knight, was immediately assumed by many to be a Soviet spy satellite, but the Soviets had no such thing in a polar orbit at that time. The stage was set for a mystery. The most famous piece of visual evidence emerged from the early days of human spaceflight. During the Mercury Atlas 7 mission in 1962, astronaut Gordon Cooper reported seeing a glowing green object ahead of his capsule during his final orbit. He reported this to the tracking station at Mutchia, Australia, and operators there claimed they could see the object on radar traveling east to west. NASA officials later attributed the sighting to a faulty panel on the capsule causing a buildup of carbon dioxide, which made Cooper hallucinate, and to an electronic anomaly at the Mutchia station. For believers, this official explanation was a classic government cover-up, a dismissal of what Cooper genuinely witnessed the Black Knight in plain view. The myth reached its photographic peak in 1998 during the Space Shuttle Endeavour's STS-88 mission, the first flight to dock with the new International Space Station. Astronauts took hundreds of photographs of the Earth and the station's components. Among them is a now iconic image that appears to show a bizarre, jagged, black object set against the curve of the Earth. It looks artificial, angular, and utterly out of place. For the Black Knight community, this was the smoking gun, the clear photo of an alien satellite. The truth, as it so often does, is far more mundane but no less fascinating in its own right. The object in the photograph has been conclusively identified as a thermal blanket lost by astronauts during an earlier spacewalk. The specific blanket was even tracked and its loss documented. It is a piece of our own space junk, ironically, watching us only in the sense that it is tumbling alongside our creations. So, if the Black Knight isn't an alien artifact, what were all those radar blips and anomalous signals? The 1960 detection was almost certainly the remains of the Discoverer program, a series of Corona spy satellite launches. Many of these launches involved placing a film return capsule into orbit, and the large, bulky upper stage of the rocket would also remain in space, tumbling end over end. These rocket bodies were dark, difficult to track, and could easily be mistaken for something else. As for the long-delayed echoes, scientists have proposed several natural explanations, including interactions with the Earth's magnetosphere that can temporarily trap radio waves before releasing them. The enduring power of the Black Knight myth doesn't come from its factual evidence, which is thin at best, but from the potent cocktail of ideas it represents. It taps into the ancient astronaut theory, the suggestion that extraterrestrials visited Earth in our distant past and perhaps guided our development. The idea of a satellite implies observation, a constant, silent witness to all of human history, our wars, our discoveries, our rise and potential fall. It is a modern-day version of the all-seeing eye of Providence, but one cast in cold, alien metal. It plays on our fear that we are not the authors of our own destiny, that our progress is being monitored and perhaps judged by a far older and more powerful intelligence. In a strange way, the truth has finally caught up with the myth. We have indeed filled our orbit with artificial objects that watch us, not from an alien intelligence but from our own. We are now surrounded by a swarm of satellites, spy satellites that capture images with astonishing clarity. communication satellites that listen to our every call, and GPS satellites that track our every move. The sky is no longer empty, it is a panopticon of our own making. The real black night isn't a single ancient relic, it is the entire interconnected web of technology we've launched into the void, a constant reminder that we are both the watchers and the watched, living in a world where privacy is vanishing into the same space that once held our most terrifying mysteries. The legend endures because in the end it was prophetic. Something is watching us from orbit, and we put it there ourselves. We have journeyed together through 25 doorways into the abyss, each one revealing a new layer of the universe's profound and terrifying nature. From the silent, drifting predators known as rogue black holes to the galaxy-shattering inevitability of Andromeda's collision with our Milky Way, we've witnessed the potential for reality itself to unravel in an instant through vacuum decay and felt the searing, sterilizing flash of a gamma-ray burst. The mysterious, unseen pull of the Great Attractor and dark flow hint at structures and forces beyond our comprehension, while the resurrected dead of zombie stars and the relentless, metronomic death rays of pulsars show us that even in death, the cosmos finds new ways to inspire dread. We grappled with the perfect, spherical emptiness of the Boötes void and the high-velocity stellar bullets flung from the galactic center. The deafening silence of the Fermi paradox left us questioning whether we are alone, lucky, or simply next in line for a great filter, while the thought experiment of quantum immortality presented a chilling possibility of eternal, lonely consciousness. We stared into the absolute dissolution of the Big Rip and weathered the invisible, radioactive rain of galactic cosmic rays. The spinning ring singularities of Care black holes offered a potential portal to unknowable realms, and the singular, unanswered whisper of the wow signal remains a haunting cosmic mystery. We saw our sun's slow-motion betrayal as a red giant and the man-made prison of the Kessler syndrome that could trap us on Earth. We explored the invisible architecture of dark matter and the creative, yet destructive, fury of neutron star mergers. The distant, icy sentinels of the Oort cloud hold a silent threat of cometary bombardment, while the quantum vacuum catastrophe suggests the very laws of physics might be perched on a precarious ledge. We felt the guiding, yet mysterious, hand of galactic magnetic fields and considered the terrifying possibility of a planetary intelligence acting as a dark Gaia. And we even looked for watchers in the sky, from the legend of the Black Knight to the very real satellites we've placed there ourselves. This collection of horrors is not meant to paralyze us with fear, but to awaken us with awe. It redefines our place in the cosmos, not as its masters or even its center, but as temporary, fragile guests in a universe that is ancient beyond measure, vast beyond comprehension, and largely indifferent to our existence. Our planet is a tiny, precious oasis in a desert of unimaginable scale and danger. This perspective is not a reason for despair, but a catalyst for profound gratitude and curiosity. Every moment of our existence is a victory against impossible odds played out on a stage of cosmic grandeur, so we turn this final reflection over to you. Which of these 25 space horrors unsettled you the most? Was it the silent, unseen threat of the rogue black hole, or the philosophical terror of the Fermi paradox's silence? Share your thoughts in the comments below. We are genuinely fascinated to hear which cosmic concept captured your imagination and sent a chill down your spine. If this journey into the dark side of the universe has left you hungry for more revelations, make sure to subscribe and hit the notification bell. Our exploration of the cosmos's greatest mysteries has only just begun.